Hello people, this is Kinematics problem set number 1 from Fraser. Joe is driving down the street at a speed of 24 meters per second when an old woman walks out in front of his car. Joe hits the brake when he is 25 meters away of the old woman and his car slows down at a rate of 4.5 meters per second squared. The old woman has a cat-like reflex and can leap over the car as long as she notices 0.35 seconds before it reached her. If she is to escape, what is the minimum distance she must see the car approaching? Okay, let's set this up by given and required. We have V1 equals 24 meters per second. V2, don't really care. Acceleration 4.5 meters per second squared, and I'll say this is negative, and I'll state the direction that's positive in a bit. Delta D is going to be 25 meters. Delta T is what we're looking for. That's one of the stuff. And the direction forward equals positive. So that's our given and required. Now analysis. We know we're going to use this kinematic equation of delta D equals V1 T plus half A squared, A T squared. Then we know 25 meters the displacement. V1 is 24 multiply T minus 4.5. That's the acceleration over 2, then T squared. I'm tired of writing delta, so bear with me. Anyways, if I just convert this into a form that people recognize, it's a quadratic equation. 24t minus 25. Okay, now you just got to plug it into your quadratic formula. Negative b plus minus square root of b squared minus 4ac all over 2a. And after you do that, you get one of your t option is 1.17 seconds. Your other one is going to be 9.497 seconds. Now, I'm going to reject this answer because guess what? They're both positive. And why I'm rejecting the larger one is because your car is going this way, but your acceleration is against you. So once you reach this point, that's the lower point in time. And after you come back to this point, that's your larger point in time. I don't know how to explain that in proper terms, but just reject it anyways. Reject because the car went backwards. Really bad writing. Now we're going to take what we just found, the time, and plug it into the equation again. This time, it's the same equation, except I'm just going to add delta D escape equals V1 T escape. I'm just adding these random subscripts to just ease my life by a little bit. Make sure you have your vector symbols. Now D is what I'm trying to find, so I'll leave that blank. V1 is still the same. It's essentially the same equation, but just with different numbers. Oh, I forgot to do something. Before that, I know T is 1.17 seconds, but her reaction time, she has a 0.35 seconds reaction time, so I have to subtract that. Equals 0.82 seconds. And if you want to do it with proper form with the equation on top, it's going to be delta D, delta T minus delta T reaction time. I like to denote it like that, equals delta T escape. Okay, now you plug in your delta T escape. Why did I write 1/3 over here? You're gonna minus half multiplied by 4.5 over 2, 0.82 squared. Now just do the math on your calculator. You should get escape time around, no, escape distance around 18.17 meters. Okay, we're not done yet. This is basically where the car will be. If that's 25 meters, that's 18.17. You want this distance because that's the old lady, and that's where the car started from. So our last step, delta D, what should I give her? Just call it min. I have no names for it. It's going to equals delta D with no prefix, no subscript, minus delta D escape. It would equal 25 minus 18.17 meters. It would equal to, let's do the math. It's going to equal 6.83 meters. Just in case, I'll put like a forward vector symbol. Actually, what is the minimum distance? Oh shit, that's not even a vector. So I don't even need a vector sign. Read the question more clearly. Therefore, minimum distance needed is, how many sig figs do I have? 2, 2, 2, okay. 6.8 meters away from car.